Alright, so today we're going to look at identifying a point of discontinuity. So the last one we looked at continuity. So here it says determine whether each function is continuous at the given x values. Justify using the continuity tests. If discontinuous, identify the type of discontinuity as infinite, jump, or removable. So the first one we have is f of x equals 1 over x minus 1 at x equals 1. So let's try it. So three tests. So the first one is check f of 1. So we're going to replace x with a 1 here. So, and that 1 came from here. That gave us 1. Okay. So we have 1 over 1 minus 1 is, 1 over 0. And we can't have a 0 in the denominator. So, no, it doesn't exist. Does not exist. D-N-E. And number 2 does. So even though this doesn't exist, we know it's because it doesn't exist. We know it's discontinuous. Now we need to know whether it's going to be. And since this doesn't exist, it's either going to be infinite, an infinite, or removable. Okay, a jump would mean that this one exists. Okay, so let's look at this one. Let's make our table. It's IKEA time. So 5 points. Probably should have made it bigger. Sorry. So we have x is 1. Okay, and we don't have a y because it doesn't exist. All right, I can put that if you want. But let's try it out. So numbers that are close to 1, really, really close. I don't know, like 0.99. 0.99 and 0.9. And on the right side we got, so really close, but bigger, is 0.01. Sorry, 1.01 and 1 point, let's go with 1. Looks good. Alright, so again, we're going to substitute these into the equation. Okay, so I'll do the first one, but then the rest I'll skip just to save time in the video. Okay, and you can see the other video if you want. So first one is 0.9, and so we have 1. Let me clear it first. 1 divided by, and then we want parentheses x. So our x was 0.9. 0.9 minus 1, and then close parentheses. So 0.9 minus 1 is negative 0.1, and then hit equals, and there you go, negative 10. All right, and I'll do the rest off camera. Alright, so I did these off camera. Alright, but if you're wondering how to do that, I just plug it into the calculator. I did it for this problem, and I did it for the others. So the next one was 0.99, and for the x, and we got a negative 100, and then, ooh, look at that jump. Ooh, from negative 10 to negative 100, that's fast. Okay, so the next one, 1.01, 1 divided by 1.01 minus 1, ended up being 100. Wow. So look at that. Negative 100, positive 100. We can get a good glimpse at what this graph is going to look like. And we have 1.1. So 1 divided by 1.1 minus 1 is 10. Negative, positive, negative, positive. Same numbers, except one is negative, one is positive. So opposite numbers. Okay. So look at that. So does that look like it's a nice flow? Like -10? Does it go in order? -100? No. It's like going this one from the left of 1. Okay. From the left of 1, it looks like it's going down. It's going down very fast. And then to the right of 1 goes from 10 and then 100. So on the right side, it's going really fast, really quickly up. All right, so it's going to look like that. So this one, because the numbers aren't close together or they don't line up, this one is, we know this one is going to be, so since this doesn't exist and the numbers don't line up, this one is going to be an infinite discontinuity. Where is that? Infinite discontinuity. And let's look at the graph, just to show. Okay, so here I put on Desmos already. And there we go. So at 1, we have 1 that's going up and 1 that's shooting down. See that? Right. And let's look at the next one. So the next one is f of x equals x minus 2 divided by x squared minus 4 at x equals 2. So first, does f of 2 exist? Does f of 2 exist? We're going to plug in 2 for the x. We have 2 minus 2 over 2 squared minus 2, sorry, 4, equals 2 minus 2 is 0, and then 2 squared is 4, so 4 minus 4 is also 0. So we have 0 over 0. Hey, it doesn't exist. Can't have a 0 in the denominator. Silly rabbit. Denominators can't have 0. Okay, now does the limit of f of x as x approaches 2 exist? IKEA time, time to make a table. X and Y. Doo, 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 doo. I'm going to put that 2 in the middle, and then we have the D and E. Alright, so a number that's really close to 2, 1.99. Super close. And a little bit farther, but still pretty close. 1.9. It looks good. Alright, now let's try the next one. A number that's bigger than 2, but really close. 2.01. Alright, and then one that's bigger than that, we can do 2.02, 2.03, 2.04, whatever you want. I'm going to put 2.1 though. Right, just keep it consistent. So let's plug it in. Same thing as before. Oops. Here we go. So I'll just do this one again. Alright, so wherever we have an x, we're going to replace it with a 2. So we have, and this one knows how we have an expression on top, right? So we're going to do parentheses 2, oops, wrong one, sorry, parentheses 1.9, 1.9 minus 2, close parentheses. Alright, that looks right. And then divided by parentheses again, 1.9 squared, 1.9, where's the squared button? Here it is, squared, and minus 4, close parentheses, equals, there we go, 2.5, oh, sorry, 0.2, not wearing my glasses. That's not a 2, that's a 5. All right. 0.256, so I'll just do 0.26. Alright, and I'll do the rest off camera. Alright, so if you look at this, I made it to the nearest hundredth because the numbers are really close. Notice that we get 0.256 here, and when it's 1.99, we got 0.251. So it's getting smaller. It's pretty close, and does not exist. And then 0.249, hey, looks like it's a smooth connection, right? And 0.244. So it looks smooth, except we're missing that 0.25 that's in between 0.251 and 0.249. So because, alright, so because it is approaching, right, on both sides, right, this one is going to be, well, because this one didn't work out, the first test didn't work out, we know it's discontinuous, but here it's going to be a removable discontinuity. So because the first one didn't work, this one, the numbers are really, looks like it's going in order, except for that missing piece. That means it's going to be something like this. It's going to be in a circle. And that circle, the open circle, means that point is not included. So there's a missing point there. Alright. So that's that. Now let's look at the graph for this one. Oops, wrong one. There we go. So at 2, and here, you can't really see it with Desmos. Maybe if you zoom in. Really close. And there you go. You see that? When we put it on 2, it's undefined. So there's a missing point. Dun dun dun. Alright, and that's called removable.